everyone. I will be talking about our latest research where we try to enhance data information exchange processes within a pool-based framework. Now, to start off, picture, if you will, a construction site where every trade pushes out information without any form of coordination. So, for example, the electrical team sends out entire blueprints when you're only asking for the outlet locations. Or the structural engineer dump entire calculation packages when you asked him only for one beam specification. Now, this is the reality of our push-based information culture. We've become experts at generating and distributing large amounts of data, but we've created a system where our project partners work on the assumption that more information is always better. Now, we've turned our system or our sophisticated BIM tools and digital workflows into an elaborate distribution system, creating basically information overload. And what is the result? Well, teams spend more and more time filtering and analyzing data than they actually spend on actually planning, designing, or building. So it's time for a change from this push-based mentality to something more effective. And therefore, we've developed a pull-based and demand-driven workflow. Our solution leverages the power of information delivery specification, or short IDS. And we can use this to articulate the precise needs of the information requesters. And IDS allows to automate compliance checks of IFC models, so we can locate and extract this information and then effectively transport the information back to the information requester using IDS as well. Now, for those of you who are not too familiar with IDS, IDS is a standard developed by Building Smart for specifying information requirements, and the good thing is that it is machine readable, as showcased here on the right. As mentioned, we can validate models using IDS, and this IDS file contains of two crucial parts. So the first one being the applicability section, so the scope of the specification or the target. So in this case, here we are targeting an element by its global ID. And we can go one step further and actually put a simple value behind this global ID to target a specific element now. The other part is the requirement section. Now, we target a specific element and we are looking for a property named as external within the property set ARC here. When we are talking about pull-based information exchange, what do we actually mean by that? So in building information modeling, we have different domain models. For example, the architectural model and the structural model, which serve different purposes. And we want to go ahead and enable the civil engineer to first articulate his needs regarding, for example, the architectural model, so the information he needs from this model, to transform this need into something machine readable, locate the information he's looking for within the architectural model, and then transport this information back to the civil engineer so he can start working on his dimensioning process. To do so, we have to overcome one challenge first, and this is how to actually communicate between those two models. Since the models describe the same project, they contain most likely the same objects, but one crucial difference is different GUIDs for the provider model and the requester model. Now, we solved this by basically analyzing geometry. This is from our prior research, where we basically analyze the objects within these two models and find the best fitting counterpart from each model. So we can have this link between the provider GUID and the requester GUID here. So now we can go ahead and start our actual pull request. So first up, we need to articulate our need. So I need the fire resistance rating for the walls, for example. Now in IDS terminology, this would translate to applicability being IFC wall, or to be more specific, the provider GUIDs as established before. And the requirements is the attribute we are looking for fire resistance rating. Now, our pull request IDS looks something like this here, where we target specific elements and look for the needed information. Now we can use this pull request IDS to simply validate the provider model now. This will scan the model for this specific element and check if the fire resistance rating is present there. And once the validation process passes, we actually take the attached value from this fire resistance rating and store it. So we get F60 for this specific wall we were looking for. Now, to transport this information back, we had to slightly adjust the usage of IDS, which is not initially designed to do pull requests or to act as an information container. We transfer, or we changed this IDS now to an answer IDS, and we had to make two changes here. So first being, we swap out the GUID now. We're not targeting the provider model, but we are now targeting the requester model with the connection of the GUIDs, and we simply add this simple value F60 as another requirement to this attribute fire resistance rating here. And you might guess it, but we go ahead and simply validate now the requester model. This will check this model if the information is present. Since the information is not present yet in this model, the validation will fail, and once the validation fails, another process kicks in and simply takes the attribute and its actual value and attaches it to the element with this specific GUID. Now, to give you a concluding overview, as detailed before, by defining the exact needs, we can translate this into something machine readable and are able to locate the exact information within the provider model, extract it and transport it to the requester model at the intended exact location. For example, this wall showcased here on the left. We have some limitations, and I want to briefly talk about two of them. First up is a rather big one, and it's the inability of IDS to analyze spatial data. So we cannot pull geometry using IDS with this approach. This is something I'm currently working on, and I will be talking about at the Forum Bauinformatik in Aachen this year, where I use a slightly or a somewhat identical approach with some additions here and there. And we have, or we are bound to some object modeling standards. So in order to find what we need, we have to know what we are looking for, or what the question is, so to say. So we can only target information when we know what the information is called. Within building information modeling, this is somewhat manageable, since the information are typically predefined in earlier project stages. So there we have a list where we can look at, but this is something that needs to be looked at more in detail. And what we are planning to do is some AI integration. So we want to enable intelligent and context-aware requests, for example, depending on the current project phase you're in. So you get suggestions from the system on which information to request depending on the role, for example. And the last point is a rather big one as well. We have to basically explore the whole process architecture and see how transforming from pushing to pulling will or would impact and reshape the whole landscape of standards and guidelines we have to follow when designing projects. Now, you can go ahead and scan the QR code and try it out yourself, and I'm more than happy to answer any follow-up questions now, or you can contact me using my email address.